I'm sharing the screen. Are you able to see the screen? Mechanical properties of fluids, session 6, Archimedes principle.
Yes, sir.
Right. So Archimedes principle states that force of buoyancy, force of buoyancy acting on a body, force of buoyancy acting on a body which is immersed partially or fully. Okay. Force of buoyancy acting on a body which is immersed partly, that means partially or fully, partly or fully, is equal to weight of the displaced liquid, weight of the displaced liquid by the body, weight of the displaced liquid by the body. Okay. So this is about Archimedes principle. Force of buoyancy acting on a body which is immersed partly or fully is equal to weight of the displaced liquid by the body. Okay. So that how to understand this? Very simple. Suppose you have a tumbler or a small glass. Okay. Where fully water is suppose filled. That water is filled fully up to top. Suppose now you can try to immerse a solid object in this. What happened? What happened to the liquid? Immediately, certain amount of liquid will spill out now. Yes or no?
Sir, yes, sir.
Yes, certain amount of liquid will be spill out. Then, now the point is telling that the buoyancy force acting on this body, FB, is equal to weight of the displaced liquid by this body. So this weight will be there now. This weight of the displaced liquid is equal to simply FB. So this is stating by Archimedes principle. Okay. So again, I'll recap the force of buoyancy acting on a body which is immersed partly or fully in a liquid, which is equal to weight of the displaced liquid by the body, weight of the displaced liquid by the body. Okay. So this is about Archimedes principle to understood. Now, based on this, we have certain applications. Are you clear this point? Weight of the displaced liquid is equal to force of buoyancy. And what is the direction of force of buoyancy? Vertically upward direction. Vertically upward direction. Okay. Now we'll go for applications of Archimedes principle. There are 4 applications is there. We'll discuss one by one. One is relative density of a solid body. We can use Archimedes principle to find the relative density. You can see here applications. In that first one, relative density. You know relative density already we discussed. Relative density of solid body. Relative density means density of body by density of water. Second is you can say relative density of liquid. Relative density of liquid. Liquid means other than water. Then we can take density of liquid by density of water. That we can find. Third one is that volume of cavity. Cavity means there is a small hole inside that. Okay. Volume of cavity in a body. Okay. That we can find by using Archimedes principle. Fourth one, the amount of impurities in a given metal. the amount of impurities or impurity in a given metal. Okay, so these are the applications of Archimedes principle that we have to understand. Right. So now I'll go for one by one. First one is the relative density of solid body.
Sir,
Yes, good morning. Yes, Roshan, tell me.
sir, can you show that page, sir?
Yes.
Sir, I heard doubt in the meaning of the Archimedes principle, sir.
Archimedes principle is that Archimedes principle stated that when a solid body fully or partially immersed in a static liquid, then the buoyancy force acting on a body is equal to the weight of the displaced liquid by that solid body. Displaced means suppose if it is fully loaded onto the glass. Suppose liquid is fully up to the brim, up to the surface. Okay, fully you have taken. Then inside you can try to keep one solid body. Then amount of fluid will spill out now, will come out of the
Yes,
glass.
sir, sir.
That amount of liquid that is coming out, that weight of the liquid displaced is equal to the buoyancy force acting on the solid body.
Okay, sir, okay.
Okay, so that is the Archimedes principle. Now, applications: relative density of solid body, relative density of liquid, that means unknown liquid other than water, volume of cavity in a body, okay, then amount of impurities in a given metal. So now we'll go for first application, relative density of solid body. Relative density of solid. Okay, this you can try to calculate. For that you can take consider a tumbler of water. In this case, you can take water only. Right. So in this, we'll keep certain amount of liquid up to certain level. Now we'll keep one body, solid body here. Let us take this is a solid body. Now in this, we need to define the densities. Here I have taken water now. Then this density of solid, you can say ds. This water, density of water, d water. Okay, very clearly you can measure. ds is the density of solid, d water is the density of water. Okay, now forces acting on this solid body. Upward direction is force of buoyancy, Fb. This is Fb, force of buoyancy. It's weight acting vertically downward. We are not bothering about weight. We are bothering about force of buoyancy. So let us take, we can define now, let W1 be the weight of the body in air medium. Okay, let W1 be the weight of body. That means if we measure weight outside water in air, then that is the W1, weight of body in air. Okay, next W2 be the weight of body in water. That means apparent weight is actually this one, weight of body in water. Okay, so weight of body in water we know already. So now this weight will be less than W2, definitely less than that of W1. Then what is buoyancy force? B is equal to, we know already, W1 weight of the body in water minus weight of the body in water. Are you agree this? In buoyancy force also I have calculated. So that is equal to what exactly? That is equal to weight of displaced fluid. That means weight of displaced water. Weight of displaced water. Okay, by the solid. So that FB is equal to W1 minus W2, that is equal to weight of displaced water, or else we can say FB also equal to what is the value? Loss of weight of body. Loss of weight of the body. Okay. So that anyway FB is equal to W1 minus W2. Then what is this FT value? What you can write? Weight of displaced water you can write now. That means you can write FB also equal to we have given one equation in the last video, that means last session, that is equal to W1 weight of the body into density of fluid or density of water by density of solid. W1 into dW by ds. How it is came, I will give you here again. FB is equal to what exactly? Weight of displaced water. So suppose let us say V is the volume of body. That means volume of body into density of water. Volume of body into density of water. No? Weight of displaced water I want. Volume of body into density of water into G. Volume of body into density of water into G means what? Weight of displaced water only. Because of it is immersed. FB means V, volume of body into density of water into G means this is the weight of displaced water. This I can write as V dW into G into, I can write ds by ds, multiplied and divide. Then I can write ds into V into dW into G. Then ds into V into G, what you can write? ds into V into G into dW by ds. ds into V into G is weight of the body, W1. Density into volume into G into dW by ds. Are you clear how it is came? FB is equal to W1 into dW by ds. Density of water by density of solid. Yes or no? Understood this? All of you up to this clear?
Yes, sir.
Then you can equate this equation 1. This is equation 2. Then from 1 and 2 what you can write? From 1 and 2, W1 into dW by ds is equal to W1 minus W2. Now I want from this equation ds by dW. From this you can write first dW by ds is equal to W1 minus W2 by W1. Okay, next I can write ds by dW. Next I can write ds by dW. From the above equation, dW by ds is equal to W1 minus W2 by W1. Now I can write reverse ds by dW. ds by dW is equal to how much? W1 by W1 minus W2. What is this ds by dW? Density of solid body by density of water. Density of solid body by density of water, what you can write? Relative density of solid. Relative density of solid is equal to ds by dW is equal to W1 by W1 minus W2, where W1 is the weight measurement in air medium, W2 is the weight measurement in water medium. Are you clear this proof? Calculation of relative density of solid body. Yes? Yes or no? Next we will go for second application. Relative density of liquid. Relative density of liquid. So let us say some unknown liquid other than water. Okay. For that you can take So consider the solid body, keep inside a unknown liquid. That unknown liquid density you have to find. So here the density of unknown liquid is, let us say, dl. Okay. Now inside this, if you keep solid body again, then we have, let us say, W1 is the weight of the solid body outside this liquid, that is weight in air, weight of solid body in air. Okay. Next, now inside this liquid, if it is kept, again you can take measurement. Then let us say there is W3, because W2 already in water I taken. That is the weight of this body. This is solid body. Weight of this solid body in unknown liquid. In unknown liquid, in a liquid, W3. Then W2 we know already. What is that W2? Weight of solid in water. That means water specifically I am mentioning. Okay. Now we know by using above equation, what you can write? Can I expect ds by dw means what I am trying to write? Density of solid by density of water is equal to W1 by W1 minus W2. Can I write that? Yes or no? We know already density of solid by density of water is equal to W1 by W1 minus W2. This is equation number 1 in this. Similarly, if you can keep the solid body of density ds, okay, then its weight is W3. Then what you can write? Density of solid by, instead of water, can I replace with the density of liquid? Density of solid by density of liquid. In that case, what you can write? W1 by W1 minus W3. Instead of W2, instead of dW, I placed dl. Then instead of W2, what you should place? W3. Equation number 2. Are you clear this step? If it is keep inside the water, then ds by dw is equal to W1 by W1 minus W2. If you keep inside the liquid the same body, then ds by dl is equal to density of liquid. Okay. Then W1 by W1 minus W3, where dw is density of water, dl is density of liquid, and ds is density of solid. Are you clear up to this? Yes or no? Hello?
Yes, sir.
Right. Now from equations 1 and 2, what you can write? From equations 1 and 2, simply you can divide 1 by 2. 1 divided by 2. 1 divided by 2 means ds by dw, ds by dw divided by ds by dl. That is equal to W1 by W1 minus W2 divided by W1 by W1 minus W3. You can see here ds cancel, W1 cancel. Then this implies this dl will come upside. That is dl by dw. dl by dw. Then dl by dw is equal to W1 minus W3 also will come upside. That is W1 minus W3 divided by W1 minus W2. So what is this dl by dw? That is the density of liquid by density of water. What is this again? Relative density only. This will give relative density now. Density of liquid by density of water. This is equation number 3. Equation number 3 will give the relative density of liquid. So this is nothing but relative density of liquid. Okay. So the relative density of liquid dl by dw is equal to W1 minus W3 by W1 minus W2, where dl is the density of liquid, dw is the density of water. dl is the density of liquid and dw is density of water. Now what about W1? Weight of the solid body in air. What about W3? Weight of the solid body in liquid. What about W2? weight of the solid body in water. So that's it. This is about the calculation of relative density of liquid. Are you clear this, all of you? Second application. Right. We'll go for third application. Volume of cavity in a given body, solid body. Next, third application. Volume of cavity. Cavity means holes inside that. Empty space. Volume of cavity in a solid body. In a solid body. So this we need to check in the case of ornaments mainly, because you can purchase with very high amount of money, costliest. In that case, the cavity should not be there. Volume of cavity in a solid body. So that we need to understand. Suppose you can take a sphere for understanding. You can take a sphere. This is like a ring first. In that you can take a small cavity. Okay. Right. Now this volume. So this is a total metal, you can imagine. Total metal. This is the small cavity. Like this, you can imagine. A sphere with the cavity inside. This we need to find volume of this cavity. Are you clear this diagram? So in this, let capital V, here two things we need to understand. Let here let capital V be the volume of metal. Try to understand. Let capital V be the volume of metal only. Volume of metal. That means what? Only this much. Whatever you have taken without cavity. This much. This is capital V be the volume of metal. Are you clear this point? And let capital M be the mass of metal. Mass of metal. Then volume of sphere. Let capital V dash be the volume of sphere. That means V dash contains both cavity and metal volume. That is the point you have to understand. Let capital be the volume of metal and M be the mass of the metal and V dash be the volume of sphere, total sphere. That means the volume of cavity means what is the meaning? V dash minus V. V dash minus V. Total volume minus volume of metal. That is delta V. That is equal to volume of cavity. Volume of cavity. Are you clear this point? You have to find this delta V. V dash minus V, volume of cavity. Understood this? Okay, then here let you can take sigma be the, you can take the symbols according to the whatever content I given. Let sigma be the density of metal. Let sigma be the density of metal. Then volume, what you can write? Normally sigma is equal to m by v, mass by volume of metal. From this volume, v is equal to m by sigma. This is equation number 1. Volume of metal is equal to mass by density. Are you clear this point? Now we can take weight of the solid body in air. Weight of the solid body in air. Let W1, you can take, let W1 be the W1 is equal to weight of the solid body in, that means solid sphere, in air, metal sphere, you can take. Then it will keep in water, suppose, let W2 is equal to weight of solid sphere in water. Are you clear this? W1, W2 weights you can calculate simply. Then we know already buoyancy force FB acting on the solid sphere. What you can write? FB is equal to W1 minus W2. W1 minus W2. But this FB, what you can write? I remember FB value. Now only you derived now. Volume of the body, total volume of the body. But FB, force of buoyancy, is equal to volume V dash, volume of the body, into density of water. Density of water. Density of water, let us say d water, density of water, into G. FB means what you can write? Volume of immersed body, V dash, into density of water into G. Density of water into G. Then you can equate this V dash into dW into G is equal to W1 minus W2. So from this, what is V dash value? V dash is equal to W1 minus W2 by density of water into G. Density of water into G. So in equation 1, we found volume of metal m by sigma. Now in this volume of total sphere, we find equation number 2, W1 minus W2 by dW into G. Then what you need to find? Volume of cavity. Then volume of cavity, delta V is equal to volume of cavity, delta V is equal to V dash minus V. What is V dash? W1 minus W2 by dW, density of water into G, minus, what is V value? Can see, go back. Here written V. V is equal to m by sigma, where sigma is the density of metal. M is the mass of the metal. Minus m by sigma. Capital M by sigma. Here, M, mass of the metal you can find, sigma, density of the metal we know, known metal. W1, weight of the sphere in air medium, W2, weight of the sphere in water medium, dW, density of water into G. Then these things already we know. From this you can find volume of cavity inside the metal. This equation you can use. Are you clear this? Third application. Yes or no? Hello? Able to following? Yes. Next we'll go for fourth application, last one. The amount of impurity in a given metal. The amount of impurity in a given metal. That means if you add impurities, what happens? Suppose you have purchased a gold, but it contains more amount of, let us say, copper. Then you lost, no? So that's why we need to find the impurity value also in a given metal. Okay. For that, what you can do, you can take a alloy. Okay. Then you can take an alloy metal contains at least 2 metals. Okay. Let us say copper and gold. Like that, you can imagine. Then you can take, let W1 be the weight. W1 be the weight of the alloy. Weight of the alloy body. That means body made up of alloy. weight of alloy in air. Okay, and W2 be the weight of same alloy in water. Weight of alloy body in water. This is common. Now let the alloy consist of two metals. Suppose let the alloy consists of two metals. Okay, then each metal has mass m1, comma m2. Each one m1, comma m2 masses. Okay, then total mass, what you can write? Total mass of alloy m is equal to m1 plus m2. This is equation number 1. Total mass m is equal to m1 plus m2. Okay, then weight in air, W1 what you can write actually? W1 is equal to m1 plus m2 into g. Weight in air means. Okay, that we can understand. Then buoyancy force, Fb. That means when it is kept inside the water, buoyancy force Fb is equal to what you can write? W1 minus W2. That we know already, this equation. Okay, but this Fb equal to how much? Equation number 3. This Fb is equal to, we know already, buoyancy force of buoyancy is equal to volume of displaced fluid into density of water into G. Okay, this is equation number 4. This is equation number 2. This is equation number 3. Okay, V into dW into G. Then what you can write from 2 and 3? From 2 and 3, what you can write? V, volume dW into G is equal to W1 minus W2. Okay. So from this we can write V is equal to W1 minus W2 by dW into G, density of water into G. This is equation number 4. But we know already these metals M1 and M2, their densities you can take D1 and D2 for given metals. That means for Li, two metals you can take of masses M1, comma M2. Let us say their densities, let us say D1, comma D2. D1, comma D2. Okay, then what you can write? Total mass and M, total volume is V. Then you can write M is equal to M1 plus M2. Okay, then you can write volume is equal to volume of the Li is equal to actually total mass M by density D. But total density we can't take. For that you can take a very simple thing. Total volume is equal to V1 volume plus V2 volume. Then V1 means what? M1 by D1 plus V2 means M2 by D2. You can write like this. Total volume of Li is volume of metal 1 plus volume of metal 2. That is M1 by D1 plus M2 by D2. Okay. Then this is equation number 5. From equation number 4 and 5, you can write as W1 minus W2 is equal to W1 minus W2 by dWg is equal to M1 by D1 plus M2 by D2. Okay. So here W1 you can find, W2 you can find, dW you can find, G you can find. M1, M2 separately we can't find. But we know one equation. M is equal to M1 plus M2. From that we can substitute M1 is equal to M2 minus M. Okay, then you can write M1 is equal to M minus M2, sorry. M minus M2. So we can substitute this M minus M2. Then M we can find. Then from that you can find M2. Okay. So that is the mass. So that M minus M2 by D1 plus M2 by D2. So by using this you can find the impurity mass value. Impurity mass value. That is about 4th application. Amount of impurity. Okay. So this is about Archimedes principle and their applications of Archimedes principle. Okay.